So now we're getting to Chapter 9, Section 3, which is multivariable linear systems. And so what happens here is we're still dealing with lines. Our exponents are still 1, but now we're dealing with more than 2 variables. We're going to have an x, a y, and a z, okay? It's a 3-variable linear system. And what happens is, guys, remember that if you have 1 variable, you only need 1 equation to solve it. If you have 2 variables, you need 2 equations to solve it. And if you have 3 variables, you're going to need 3 equations to solve it. And so we're going to work on that today. So there's a long list of this. Again, it's a little confusing, but it says basically pick 2 out of the 3 equations, cancel out one of the variables, and the equation that'll be left over is your new one. Then you're going to pick the third equation with either one of the other 2 that you used in step 1 here, okay? And you're going to cancel out that same variable and you're going to get a new 2. So what's going to happen is in step 3, you're going to have 2 equations. We'll call it new 1 and new 2, right? And you're going to use that equation to cancel out a second variable. And that'll leave you with one final variable to solve for. Once you solve for that variable, you're going to go back into the equations in step 3, and you're going to plug that in to find a second variable. And once you find that second variable, the value, then you're going to go and plug it back into one of the original equations to get the third variable. So it sounds very confusing. There is a process to this. It's not difficult, but you have to be meticulous. You have to be very organized. And we're going to do a ton of examples to help you with that. So remember the rules on this, right, guys? What we're going to do is we're going to pick 2 and we're going to solve for we're going to cancel out a variable in those 2. So I'm going to come over to here and I'm going to start that one. So I'm going to do x minus 2y plus 3z equals 9 and minus x plus 3y equals negative 4. I notice my x's are already opposites. That's why I picked them, because I already can get it down to 2 variables. Okay, so right now we have y plus 3z equals 5. And this is known as the new 1, right? In the other place. You don't need to do that, but again, it's just if you want to do it. Then I'm going to take the next 2 and I'm going to eliminate the same variable. So I've got negative x plus 3y equals negative 4. And I have 2x minus 5y plus 5z equals 17. And again, since I eliminated x here, I'm going to have to eliminate the x's in this one. And so I'm going to multiply the top one by 2. And I'll rewrite it down here. And so I'm going to get minus 2x plus 6y equals negative 8. And then now I can cancel that one, right? When I do my math, I'm going to get y plus 5z equals 9. So this is what's known as my new 2, right? My new 2 equation or whatever. Okay, so when I come over to here now, I'm going to take those 2 new equations, y plus 3z equals 5 and y plus 5z equals 9. And now notice I have a 2-variable equation. So I'm going to solve and eliminate one of those 2 variables. Again, I'll take this one and multiply by negative 1 to make my y opposites, right? And I'll get negative 5, and then these cancel, and I'll get 2z equals 4, and z equals 2. And so I have my first solution is z equals 2. All right, so now that I have that, my solution here is going to be an x, a y, and a z coordinate. So I already have my z coordinate, and it's 2. Then what I'm going to do is I'm going to now plug that in to either new 1 or new 2, right? Basically, I have z. So I can plug z into either this equation here or this equation here to solve for y. So that's what I'm going to do. So I'll use the top one. Y plus 5z equals 9. Y plus 5 times 2 equals 9. Y plus 10 equals 9, y equals negative 1. And so now I have my next variable, negative 1. So now I have a y and a z, and I can go back into any of the original equations and solve for the last variable. So I'll just start with this first one. So I'll do x minus 2 times y plus 3 times z equals 9. So x plus 2 plus 6 equals 9, x plus 8 equals 9, x equals 1. And so 1, 1, 2 are my three solutions. And if you want to double check that, you can plug it into any of the other two. So I'll try this one to just ensure it. So 2 times x, which is 1, minus 5 times negative 1, which is y, plus 5 times 2, which is z, should equal 17. 2 plus 5 plus 10 is 17. 17 equals 17, and it works. And so again, that's how you solve it. It's long, it's tedious, but it's completely doable and actually quite simple. Just take your time. Okay, so again, here we have another system we have to solve. We're going to have a bunch of these examples. I'm going to start again. I'm going to take 2 of them, and I'm going to create my new 1 and my new 2. So I'm going to start with the first 2. 3x plus 9y plus 6z equals 3, and 2x plus y minus z equals 2. And since there's no opposites right now, but I do see that my z's have opposite signs, I'm just going to multiply the bottom one by 6. So that's going to be 12x plus 6y minus 6z equals 12. Eliminate that. And now you're going to notice that my x's become 15x, my y's are 15y, my z's eliminate, and I'm left with 15. 12 plus z is 15. So this is my new 1, right? Then I'm going to go to the next one. Well, I know I have to start with the bottom one that I didn't use, x plus y plus z equals 2. And I have to eliminate the z, because I eliminated the z in the other one. So I'm going to use this one, because it's an opposite. It's already a negative. So 2x plus y minus z equals 2. And I think, let me see, plus z minus z, right? So they're already opposites. So I'm going to eliminate those right off the bat. So 3x plus 2y equals 4. And this is my new 2. So I have my, now I have two variable equations. So I'm going to write them over here. So I have 15x plus 15y equals 15. And I have 3x plus 2y equals 4. The ones I'm going to make opposite, I'm just looking at it, and the x's look really easy to eliminate here. I'm just going to multiply by negative 5. So let me just do that. So that's going to be negative 15x minus 10y equals negative 20. And I'm going to combine. My x's now cancel, and I've got 5y equals negative 5. So y equals negative 1. So I have my first solution. Again, I've got my x, my y, and my z. And my first solution is the y value. Okay? So now I'm going to go back into any one of these two original equations, new 1 or new 2. And I'm going to plug negative 1 in for y to find the variable. So I'll go to this one. 3x plus 2y equals 4. So 3x plus 2 times negative 1 equals 4. 3x minus 2 equals 4. 3x equals 6. And x equals 2. So guess what? I just found my second solution. Now I have y and I have x. And so I have to go back into any one of these three to figure it out. Well, I'm going to go into the bottom one because that seems like the easiest one of all, right? That bottom one is x plus y plus z equals 2. X is 2. Y is negative 1. I've got z, which is unknown, and it equals 2. So 2 plus negative 1 is 1, plus z equals 2. Subtract 1 from both sides, and z equals 1. And there's my solution. 2, negative 1, and 1. And if you plug it into any of these other equations, you will see that it will work, okay? Or it should. So let me just kind of, let's just check it, right? Let's check one more time. So 2 times 2 plus negative 1 minus 1 equals 2. 4 minus 1 equals 2. 2 equals 2, and it worked. Okay? Again, we keep going. We don't know what kind of answer. Sometimes we're going to get a no solution. You'll see it. You'll get some false statement along the way. You'll get some infinitely many. It might be the same line 3 times. And those will probably come up at some point in here. Again, I'm going to start with my first 2. And I'm going to do 2x plus y plus z equals 9 minus x minus y plus z equals 1. I'm going to eliminate my y's because they're already opposites. So x plus 2z equals 10. Oops, not 2x. X plus 2z equals 10. So this is the new one, right? You don't have to do that, but I'm just kind of trying to be consistent with the notes. And then I'll do the button that minus x minus y. Well, here, you know what? I know I have to eliminate y. And the equation I have to use is the bottom one. It's 3x minus y plus z equals 9. And notice it's a minus y, so I'm going to use the top one because it's already set up to be an opposite. And it's already going to eliminate my y's. So I don't have to multiply by anything. So 5x plus 2z equals 18. So this is new 2, right? So now I'm going to take those 2 together. X plus 2z equals 10. 5x plus 2z equals 18, and I'm going to try to eliminate one of them. So what I'm going to do is I'm going to multiply the top by -1. That's going to be minus x minus 2z equals minus 10. That way my z's cancel, and I'm going to get 4x equals 8, so x equals 2. So again, I know I'm going to have an x, a y, and a z. In this case, my x is 2. So now I'm going to use one of these 2 to find z. So I plug in, my original equation, right, I know is x plus 2z equals 10. If x is 2, so 2 plus 2z equals 10. 2z equals 8, which means z equals 4. So now I have my third variable there. And so again, now I'm going to go into one of the original equations to find the other one. And I think I'm going to pick this one because there's no negatives in it. So I'll come to that one and I'll do 2x plus y plus z equals 9. X is 2. Y we don't know. And z is 4. So 4 plus y plus 4 equals 9. 8 plus y equals 9. Y equals 1. And so there's my 3 values. It's 2, 1, and 4. And again, you should check into one of the other equations, like maybe this one. Let's check it. So 3x minus y plus z is 9. 3 times 2 minus 1 plus 4 equals 9. 6 minus 1 plus 4 is 9. 5 plus 4 is 9. 9 equals 9. Check. It worked. Okay, and on a test you should check it because it's silly to get it wrong for not checking. Obviously I would probably check after I've done all the problems because you don't want to run out of time, but probably checking is a good thing. Alright, so we keep going. Again, the pattern repeats itself every single time. So I take the first 2, x minus 3y plus z equals 1, and 2x minus y minus 2z equals 2. What I'm going to do, I think, is I will multiply by 2, and that's going to make my z's cancel. So that's what I'm going to do. I'm going to multiply the top one by 2. 2x minus 6y plus 2z equals 2. I'm going to get 4x minus 7y equals 4. So this is my new one, right? Then I'm going to go and get the last one, which I haven't done yet. So x plus 2y minus 3z equals -1. I know I have to eliminate my z's, and I think the easiest one to use for that would be the top one. So x minus 3y plus z equals 1, and I'll multiply this one by 3. So 3x minus 9y plus 3z equals 3. And I'm going to combine, so I get 4x minus 7y. My z's cancel, equals 2. And this is new 2. So now I have those 2. And I'm now able to use those 2 4x minus 7y equals 4. 4x minus 7y equals 2 to create my new one. So I'm going to just multiply by a negative. I already see there's a pattern happening. If you notice, there's no way that they both have the same left side, yet the right side is different. So this is going to be a special solution, but I'm going to work it out as if you didn't notice that. And I'm going to multiply the top by -1, and that makes my opposites. Let's say I'm trying to cancel my x's. And what you're going to see happening is you're going to get 0, and your y's are going to cancel too, and all of a sudden you're going to have a -4. You're going to have 0 equals -4. This is a false statement, okay? So what that means is there's a false statement here. This is a no solution, okay? These two lines specifically are parallel to each other. So there's no solution there for those. So if those lines are parallel, then there's going to be no solution for the entire expression, because remember, or the system is where all three lines intersect. So if two of the three don't intersect, then there is no solution. So this is a no solution, and you can stop right here. You don't need to keep going. Okay, so we're going to keep going here. We're going to go to the next one. Again, I'm going to do the first two. I'm going to do x plus y minus 3z equals -1. And I'm going to do y minus z equals 0. And so what I'm going to do here, I think I'm going to multiply the bottom by -1. And that way I can eliminate my, my y's. So I'll multiply by -1. And here I'm going to get, let me not do that line. Sorry. Okay, so I'm going to get -y plus z equals 0. That cancels. And then I'm going to get x, my y's cancel, minus 2z equals -1. And I can, that'll be my new 1, right? Then I'm going to take the bottom, -x plus 2y equals 1. And I'm going to use one of the other equations. Now, it doesn't do me any good to do this equation because this one has no x. And so I know I want to cancel out the y's, but I just think, I don't know, I think that one's weird using that. I could, but I just think it's confusing. So I'm going to try to use this one, okay? So I'm going to do x plus y minus 3z equals -1. Again, I'm trying to get rid of the y's, so I'm going to have to multiply this one by -2, okay? So I'm going to get minus 2x minus 2y plus 6z equals 2. And now I'm going to combine them. So I get minus 3x, these cancel, plus 6z equals 3. And now I have new 2. So now I have two equations with x and z, which is kind of what I wanted to get to, right? So I've got x minus 2z equals -1, and I have -3x plus 6z equals 3. So once I get to here, how am I going to work on eliminating this? I'm going to multiply both by 3. But, well, not both, but that whole equation by 3. That's going to become 3x minus 6z minus 3, okay? And so then I notice, oh, wow, my x's cancel, my z's cancel, and my numbers. So 0 equals 0. So this is a true statement, which means this is all real solutions, or you can call it infinitely many solutions. And so what happens is these two lines are exactly the same line, okay? So the first two lines are the same line. So you can keep going, but you don't really have to. At this point, you know you're going to have infinitely many solutions, and we're not going to ask you to write it any other way. So we have two more examples going on here in example 8. Let's do this one. We're going to come over to here, and again, we're going to go first two, x minus y plus z equals 4. And we're going to get x plus 3y minus 2z equals -3. And I want to eliminate, I could really pick any of them, but maybe I'll pick z. I'll multiply the top by 2, okay? So the top is going to become 2x minus 2y plus 2z equals 8. Cancel that out. I'm going to get 3x plus y, the z's cancel, equals 5. That's my new 1, right? And then I'll go to new 2. So 3x plus 2y plus 2z equals 6. I know my goal is to cancel the z's, and I think it's going to be pretty easy for me to cancel the z in this one, okay? Because notice the z's are already opposites of each other. So obviously all I have to do is add these. 4x plus 5y equals 3. So this is new 2, okay? So I take the first equation, 3x plus y equals 5, or new 1 rather. I take new 2, and I have to eliminate another variable. So for me, I think it's probably easier to just multiply the top by negative 5, okay? So when I do that, I don't know why I keep doing this line here. When I do that, I'm going to end up getting minus 15x minus 5y equals negative 25. Negative 11x, my y's cancel, equals negative 22. X equals 2. I have my first solution. I'm going to plug it into one of these. So 3x plus y is 5. 3 times 2 plus y is 5. 6 plus y is 5. Y equals negative 1. And then I'm going to take both of those and plug it into one of the originals, which I'll do this one. X minus y plus z is 4. X is 2 minus negative 1 plus z is 4. 2 minus negative 1 is 3 plus z is 4. Z equals 1. And so my solutions are 2, negative 1, and 1. And again, I highly recommend you plug into one of the other ones. I plugged it into this one to get my final value, so I'm going to plug it into one of the other ones, and I'm going to probably do this one just to check, okay? So again, I've got 2 plus 3 times y minus 2 times z equals negative 3. 2 minus 3 minus 2 equals minus 3. That's 2 minus 5 equals minus 3, minus 3 equals minus 3, and it works, okay? So again, you don't want to plug it into the one you just used over here. You want to plug it into a second one, okay, to make sure that it works, okay? And last but not least, we're on this last one. And so we come to this last example. I'm going to take the first two again. I try to be consistent. X minus 2y plus z equals 4. 3x minus 6y plus 3z equals 7. I'm going to try to eliminate, I'll try to eliminate my z's, and so I'll multiply by negative 3. When I do that, I get minus 3x plus 6y minus 3z equals minus 12. And when I go to cancel, right, and add, I notice that the x's canceled, the y's canceled, the z's canceled, and my constants became negative 5. So 0 equals negative 5 is a false statement. And so that means that these two lines are parallel. There's no solution. And so if two lines are parallel, then it doesn't matter what happens with the third. There's not going to be a point where they all share, because the first two don't share anything. So this is a no solution, and you're done. You have nothing left to do.